Why is space so unimaginably cold? Why is it so vast and empty with so little truly there? For us, Earth is a vibrant, bustling place, teeming with life, warmth, and light. But step outside our atmosphere and you're plunged into an environment so extreme, so desolate, it defies everyday comprehension. The universe, in its grandest scale, is a cosmic void. It's a place where temperatures plummet to absolute zero, where billions of light years separate even the closest galaxies, and where most of what exists isn't even visible. This isn't just a distant fact. It's a fundamental mystery that shapes our very existence and the ultimate fate of everything. Prepare to have your mind expanded and your sense of scale shattered, because we're diving deep into the chilling truths about the universe's most dominant features, its overwhelming coldness and astonishing emptiness. Stay with us until the very end to understand why this vast cosmic void is actually essential for life as we know it. Welcome to Young Curiosity, where we unravel the mysteries that shape our world. If you're fascinated by the biggest questions in science and the cosmos, you're in the right place. Please take a moment to smash that like button, subscribe to Young Curiosity for more mind-bending insights, and tell us in the comments where you're watching from. Your support helps us bring these incredible topics to life. First, let's confront the cold. When we talk about cold in space, we're talking about temperatures that make Antarctica feel like a warm beach. Deep space isn't just chilly. It's incredibly close to absolute zero, which is 273.15 degrees Celsius or 459.67 degrees Fahrenheit. This is the theoretical point where all molecular motion stops. Why is it so cold? On Earth, heat travels through conduction, direct contact like touching a hot stove, or convection, movement of fluids like warm air rising. In the vastness of space, there's simply too little matter to conduct heat. Effectively, and almost no medium for convection. The primary way heat travels in space is through radiation. Imagine the sun's rays warming your skin. If you're exposed to direct sunlight in space, you'd be extremely hot, even boiling. But step into the shade or drift far from any stars, and there's virtually nothing to radiate heat to you. The vacuum of space is an almost perfect insulator, meaning any heat an object possesses quickly radiates away into the vast darkness, with no external source to replace it. This is why astronauts wear highly specialized suits and spacecraft need complex thermal regulation systems involving radiators and blankets. Without a constant energy source, objects in deep space lose their thermal energy until they approach the bone-chilling temperatures of absolute zero. It's a chilling reality for anything unprotected by a nearby star or artificial heating. What's the coldest place you've ever been? Share your experience in the comments. Next, let's tackle the emptiness. When we look up at the night sky, we see countless stars glittering like diamonds, but that's just a tiny fraction of the universe. The vast majority of the universe is vacuum, colossal stretches of nearly nothing. Even within galaxies, stars are incredibly far apart. Our own sun, a relatively average star, is about 4.2 light-years from its nearest star neighbor, Proxima Centauri. To put that into perspective, if the sun were the size of a grapefruit in Los Angeles, Proxima Centauri would be another grapefruit all the way across the United States and New York City. The space between galaxies is even more astonishingly empty. Imagine a single grain of sand in a volume the size of the entire planet Earth. That's roughly the density of matter in intergalactic space. This extreme emptiness is a direct fundamental consequence of the Big Bang. While the universe started incredibly dense and hot, it has been expanding rapidly for 13.8 billion years. This expansion is stretching space itself, acting like an invisible cosmic elastic band, pulling galaxies and vast clusters of galaxies further and further apart, creating enormous cosmic voids. These voids aren't perfectly empty, but they contain far, far less matter, perhaps just a few hydrogen atoms per cubic meter, compared to the dense filaments and walls of galaxies that form the large-scale structure of the universe. So, this combination of extreme cold and vast emptiness might seem bleak, even hostile, but it's actually crucial for life as we know it. The cold allows for the formation of vast, stable structures. Without the immense cold emptiness, gravity wouldn't have the space or the billions of years required to pull scattered matter together into the intricate structures of stars, planets, and galaxies. The early universe would have remained a hot, uniform soup, never allowing for the complex chemistry needed for life. The very expansion that creates the emptiness also cools the universe from its fiery Big Bang origin, allowing atoms to form and eventually clump together. Furthermore, this emptiness ensures that the energy from stars, which is absolutely vital for providing the warmth and light necessary for life, can travel vast distances without being absorbed or scattered. If space were densely packed with matter, starlight wouldn't reach us, and planets wouldn't receive the energy they need. It's a delicate and paradoxical balance. The enormous voids provide the necessary cosmic canvas and time for structure and complexity to emerge, while the localized pockets of matter, like our vibrant solar system, provide the specific conditions for life to flourish. But the emptiness holds another profound mystery: dark matter and dark energy. We know the universe is overwhelmingly empty, but even the visible matter, everything we can see, touch, and measure like stars, planets, gas, and dust, only accounts for about 5% of the total mass energy of the universe. Roughly 27% is composed of dark matter, an invisible, enigmatic substance that doesn't interact with light or any other form of electromagnetic radiation. This means we can't see it directly, we can't detect it with our telescopes, and it doesn't absorb, reflect, or emit light. We only know it's there because of its powerful gravitational effects on visible matter. It acts like an unseen cosmic scaffold or glue, providing the extra gravitational pull necessary to hold galaxies and massive galaxy clusters together, preventing them from flying apart due to their rotation. And the remaining 68% is dark energy, an even more mysterious force or property of space itself. It's thought to be responsible for the accelerating expansion of the universe. It acts like a cosmic anti-gravity, pushing everything further and further apart at an ever-increasing rate. The vast majority of the universe, then, is made of stuff we can't see, can't touch, and barely understand, existing within a vast, cold vacuum. What do you think dark matter and dark energy really are? Let us know your theories. This accelerating expansion driven by dark energy leads to a chilling ultimate fate for the universe, the Big Freeze, also known as heat death. As space continues to expand and stretch, everything gets further and further apart. Billions of years from now, galaxies will eventually move so far away from each other that their light will never reach us. Stars will burn out, black holes will slowly evaporate through Hawking radiation, and the universe will become an incredibly dilute, incredibly cold, and incredibly dark place. All matter will be spread so thin that interactions will become impossible, and the temperature everywhere will relentlessly approach absolute zero. It's a truly bleak and lonely distant future, billions and even trillions of years away, but it's currently the dominant theory for how our cosmic story will ultimately end. So, the universe is cold, because there's simply too little matter to hold on to heat or transfer it effectively, and it's overwhelmingly empty because it's constantly expanding, pulling everything apart at an accelerating rate. But paradoxically, this seemingly hostile, cold, and empty canvas is precisely what allowed the incredible complexity, warmth, and vibrancy of life to emerge in tiny, unique pockets like our Earth. It's a testament to the immense scale, the profound mysteries, and the delicate balances of the cosmos, reminding us how precious and unique our own small, vibrant corner of the universe truly is. The journey into the depths of space is just beginning, and its ultimate destination remains one of young curiosity's greatest mysteries. What other cosmic questions keep you awake at night? Share your thoughts in the comments below, and thanks for watching.